Hi everyone, in this video we're going to take a look at linear functions. And after this session, you will be able to do these 6 things. Calculate a line slope, write the point slope form of a line, write and graph the slope-intercept form, also recognize and graph horizontal vertical lines, also taking a look at general form, and then finally use intercepts, x and y intercepts, to graph the general form of a line's equation. First, let's take a look at a linear rate using Gwinnett County teacher salary. This may be different because I'm using data from last year. Here is the Gwinnett County teacher salary. When they first start, it starts at $48,646. This is with a bachelor's degree, and say going on to the 5th year, they go up to $52,936. Now for higher degrees, it is going to be higher, but this is a Gwinnett teacher with a college degree. Let's determine the starting value. When they start, when they first get the first teaching position, that is the y-intercept. Okay, so we know when they start, this is when x is equal to 0. If we say the first, here's x and this is y, so they make $48,646. Let's also take a look at how much does the salary increase per year, and that's known as a slope. And so if you look to see how much it goes up every year, and I just did the math and take the difference between the two, it's 858 per year that they go up. So here is the salary increase each year, and that is known as the slope. Okay, so let's determine the linear equation of the salary depending on each year. So we would say the salary would equal what the base is, what the start salary is. Oops, it's 646. Plus 858 per year. And then let's see if we were to calculate all the way to the 20th year, what would be the salary for a teacher with 20 years of experience? So that would be the salary for a 20-year. It would be 48,646 plus 858 times 20. We put that in the calculator, and they would be at the 20th year, $65,806. So now that we have an equation, we could calculate for any year, right? If we have this equation, and that's what really linear equations are for, to predict values at certain points. So let's go into the formal definition of slope. Here, the slope, we can say this is a change where you're measuring the change of a line. The slope m of a line through distinct points x1, y1, and x2, y2 is, we use the variable m, y2 minus y1 over x2 minus x1. You probably all know this formula, but this is also known as rise over run. The rise is we either go up or down depending on whether the slope is positive or negative. The run, you're always going to go right and never left. Okay, so here's the rise, and then here's the run. You make sure you have that written down in your notebook. Okay, let's do some practice problems. Let's graph the line passing through the points -8, 9, and -2, -9, and then calculate the slope of the line. So -8, 9, go to x is -8, not 9 should be up here. So there's negative 8, 9. And negative 2, negative 9 would be down here. And if we were to connect the two, let's kind of draw a very rough sketch of a line connecting the two lines. The 2 points. Okay, let's calculate the slope using that formula. Let's label, it's easy to label your points, x1, y1, x2, y2. And the subscripts just denote which point it comes from. So the x1, y1 is because it's from the first point, x2, y2 because these are the x and y values from the second point. Now, I'm going to use the slope formula, y2 minus y1 over x2 minus x1. So y2 is negative 9, minus y1 is 9, x2 is negative 2, minus x1 is negative 8. Now negative 9 minus 9 is negative 18. This becomes negative 2 plus 8 because the double negatives become addition. So negative 2 plus 8 is going to give us 6. Negative 18 divided by 6 is negative 3. Now that's a slope, a negative 3 slope. What that means is any number, we can make it a rise over a run or by putting a 1 underneath. So this tells me from the first point, negative 8, 9, to the second point, negative 2, negative 9, we would have to go down 3 because of that negative sign, and to the right 1 each time. So those are our kind of steps. So if you look here, we go down 3 over 1, down 3 over 1, and this pattern repeats all throughout the this linear graph, down 3 over 1. And so there's our slope. Okay, let's do another one here. Let's graph passing through the following pair of points. We're going to calculate the slope of this line. And we have negative 3, negative 2. That's right here. And negative 3, 5. That's right here. There's negative 3, negative 2. And negative 3, 5. And if we draw a line through the points, it looks like a line that goes straight down. So let's look at our slope. It's y2, which is the 5, minus, oh, forgot to label these. Let's label this. x1, y1, x2, y2. So 5 minus y1 is negative 2. x2 is negative 3. I'm going to subtract x1, which is negative 3. 5 plus 2 is 7. Negative 3 plus 3 is 0. And 7 divided by 0 is a number that can't be calculated. So we say it's undefined. What that means is any vertical lines, and we say it doesn't really have a slope. The slope is undefined. Okay. So those were two types. So we had looked at a slope where, let me go to the previous page, where it fell from left to right. And you can see because the line falls from left to right, it's a negative slope. When the line falls straight down, this is an undefined slope. And so there's two more possibilities. There's actually, oops, let me erase that. Okay, there we go. The fourth possibilities of a line slope, m, where if you have y equals 3x, our slope is a value in front of x, 3. And you can see because it's 3, we can write that as 3 over 1. We would go up 3 and right 1 each time. So from the y-intercept, we would go up 3 over 1, up 3 over 1. You can see because it's a positive slope, positive slopes have lines that rise from left to right. Here, the slope of y equals negative 2/3 x is negative 2 over 3. which means we would go down 2 over 1, go down to, down to over 3 rather. And this is a negative slope. And negative slopes mean that the line falls from left to right. We have y equals -4. You can see there is no x term here. It's just y equals -4. I mean, it's a straight horizontal line through -4 on the y-axis. This is a slope of 0, and it's any horizontal lines have slopes that are 0. The previous example, we saw a line that was vertical. Vertical lines, again, like the previous page example, this is an undefined slope. Okay, so let's go over the common form for linear equations. We call it the slope-intercept form. We should really call it the slope y-intercept form because this intercept is for the y-intercept, and it is y equals mx plus b, where our m is the slope, our y and x are the variables in the equation, and b is the y-intercept. As a point, we write the y-intercept as 0b. So from this form, we can tell what the slope is, we can tell what the y-intercept is. We can't automatically tell what the x-intercept is, but we can find it by doing some work. Okay, so let's graph some of these functions. Y equals 2 over 5x minus 3. The slope is the term in front of the x. Here's a 2 over 5. Which I know that our slope would have a slope of up to and right 5 each time. Those are our kind of like steps. What's the y-intercept is -3. In the homework system, my math lab just takes -3, but I also want you to know how to write it as a point, which is 0, -3. First, let's plot the y-intercept. Actually, I should have wrote it there, 0, -3. So we're going to go to the y-axis, go to 0, -3. There's our point. Next, from the y-intercept, we're going to move 2 units up and then 5 units to the right. So we go up 2 over 5, 1, 2, 3, 4, 5. You can make another point up to over 5, but you really only need 2 points to make a graph or linear function. So there's our graph, y equals 2 over 5x minus 3. Let's do another one. Okay, graph 4, y equals 6x minus 2. Our slope is 6. Or 6 over 1, which means we would go up 6 and to the right 1. Our y-intercept is -2 or 0, -2. So we would start at the y-intercept, plot it down on the y-axis, always on the y-axis, never on the x-axis, and then go up 6, 1, 2, 3, 4, 5, 6 over 1. Let's just do one more point, 1, 2, 3, 4, 5, 6 over 1. So here's our line, more or less. You can see because it's a positive line, it rises upwards. Okay, another one, y equals -2x plus 4. Our slope is -2. Our y-intercept is 4 or 0, 4. Always start on the y-axis at 0, 4. This time our slope is -2. Or as a rise over a run fraction, -2 over 1. So this time we have to go down 2 because it's negative and always to the right 1. So down 2 over 1. Let's just do one more, down 2 over 1. And so here's a line, and it shouldn't be a surprise that the line falls from left to right since it is a negative slope. Okay, y equals 2/3 x minus 5. Another one here. Our slope is 2 over 3. Our slope is -5. As a point is 0, -5. The top number is our rise. So we go up to the bottom number is our run. So right 3. So 0, -5. And then we go up 2 and over 5. 3. I'm sorry, 3. I got confused there for a second with the y-intercept. Up 2 over 3, up 2 over 3. So those, connect that and make our line. Okay, one more, y equals -3/8 x. And you see there's nothing being added here. It's actually 0. So our y-intercept is 0 or 0, 0. Our slope is -3 over 8. Always stick the negative up with the numerator or your rise. So this would be down 3 over to the right 8. So we start at 0, 0, go down 3 over 8. I'll just connect those 2 points. You could also, let me make this more accurate. So, okay. We could also use a graphing calculator to graph these. And we can do that by, let's pull up our graphing calculator. And let's graph 6, number 6. Number 6 was, let's go to y equals 2 over 3x minus 5. Let me go to graph. And so here's a graph that we got. You can see that it has a y-intercept of -5. You can also look at all the values under the table by going to second graph, because table is in blue. And you can see that it gives you other points where you can use the graph. Another point would be -3, -7. We know 0, -5. There's 3, -3, 6, -1. So you can also use these table of ordered pairs to graph your line. Okay, let's go back to our main page. Okay, so we just looked at various linear equations in slope-intercept form, where it was really easy to tell what the y-intercept is, plot it, and use a graph slope to find the second line. Another less common, although we still use it, is the point slope form of a linear equation. And this is used when you have a slope and the point. And so the way we express this is y minus y1, the y value of the first point that's given, equals m, which is your slope, x minus x1. This x1, y1, this is from your point, x1, y1, and then this is your slope. With this equation, it's really easy to tell what the slope is, and also easy to use if you have the point. With this form, you can't tell what the y-intercept is. You would have to rearrange and do some work to get the y-intercept. Okay, let's take a look at number 8. Writing the equation for the line, passing through 7, 9, and it has a x-intercept of 1. We want this in point slope form and slope-intercept form. So it actually wants it in both forms. For both of these, we need the slope, right? The slope, point slope form, you need slope, slope-intercept form, you also need the slope. So we need to calculate the slope first. Let's calculate the slope. How will we calculate the slope when we don't know the slope? Well, as long as you have 2 points, you can calculate the slope. The first point that's given is 7, 9. The second point that's given is the x-intercept of 1. What that means is the x-intercept is 1, 0. So we have 2 points. We can label it x1, y1, x2, y2, and use the slope formula, y2 minus y1 over x2 minus x1. So y2 is 0, minus y1 is 9. X2 is 1, minus x1 is 7. So 0 minus 9 is -9. 1 minus 7 is -6. And -9 over -6 reduces to 3/2. So there's our slope. And so we can put it in point slope form. So I'll do part A first. Point slope form is y minus y1 equals m times x minus x1. And as long as we have a point and we have a slope, we can use this line. So y minus y1, what do we plug in here? Well, we can plug in the first point. You could also plug in the second point, but I'll just go with the first point. y1, the y value from that point is 9, equals the m. We calculate it as 3 over 2. X minus the x1 value from that first point is 7. And that's it. You just leave it in that form with the parentheses intact. Y minus 3 over 2, x minus 7. All right, now to get into slope-intercept form, we want to rewrite this form into y equals mx plus b. In order to do that, we have to distribute the 3 halves and then add the 9 so that the y is isolated. So let's distribute the 3 halves first. 3 halves times x is 3 over 2x minus 3 halves times negative 7. That's 21 over 2. This 3 halves times 7 over 1. We multiply fraction straight across, so that's 21 over 2. And then we add the 9 to both sides. So y equals 3 halves x. To do 21 over 2 plus 9, what we need to do is whenever we add or subtract fractions, we need common denominators. So 21 over 2 plus 9 over 1. We want a common denominator of 2. So we have negative 21 over 2 plus 18 over 2. Negative 21 halves plus 18 halves is negative 3 over 2. You could also, of course, just use a calculator and make your calculator do all the fractions for you. And I'll go ahead and hop on over. But just first write that in slope-intercept form. So our slope-intercept form is y equals 3 over 2x minus 3 halves. So how would we have calculated that using the calculator? Just plug it in. Okay, so let me quit out of this. And so we could have, the first part was 3 over 2. We multiply that by negative 7. And that we get negative 10.5, which as a fraction, you would go to math and go to frac. That was negative 21 over 2. And then if we add 9 to both sides, so isolate the y, we get negative 3 halves as our y-intercept. Let's just graph it to see what it looks like. Why not? This would be 3 over 2x minus 3 over 2. We graph it. Here's the linear equation. Of course, you can see what are my table of values. You get some nice points here without the decimals, and you can always plot these ordered pairs to graph this line nicely on the graph. Okay, let's try here, number 8. Number 8, I would like you to, oh, this is number 8, so this should actually be number 9. Okay. Number 9, I would like you to try on your own. First, calculate the slope using these 2 points, and then find the point slope form and the slope intercept form. Okay, so this one I want you to try. Okay, let's move on to the general form of a linear equation. Ax plus by plus c equals 0, where a, b, and c are real numbers. Actually, let me just write that down instead of reading it out loud. So general form is in this form, and a and b and c are just coefficients, and your x and y are variables. So let's look at the first case of where our linear equation is written in general form. We have 4x plus 7y minus 28 equals 0. And let's rewrite this in slope-intercept form. Again, what's slope-intercept form? That's the y equals mx plus b form. And then we're going to graph this. So for that, let's rewrite it down here. 4x plus 7y minus 28 equals 0. To get it into slope-intercept form, you want to rewrite it so that the y is by itself on the left-hand side. So to do that, we're going to subtract the 4x on both sides of the equation. And you're also going to add the 28 on both sides of the equation. What that helps us to do is it cancels the 4x on the left and the negative 28 on the left. And in our second step, we got 7y equals negative 4x plus 28. And of course, to get rid of this 7 times y, let's divide everything by 7. The negative 4x divide by 7. 28, you divide that by 7. The 7 and the 7, we cancel that away. So we have y equals negative 4 over 7x. There's our slope. And 28 over 7, that actually reduces nicely to 4. And that is our y-intercept. So once we have our y-intercept, we can go on the y-axis and put our first value, our starting point, at 4 or 0, 4. And then, of course, the slope tells us that because it's negative, we will go down 4, 1, 2, 3, 4 over 7. And I'll just stop there. There's our rough sketch of the line. Of course, you can graph it on the graphing calculator as well and do it that way. Okay, so you can see that our slope, using our slope, we can get the x-intercept. But I wanted to show you another method of doing this, just finding the x and y-intercept without rewriting it into slope-intercept form. I'm going to make a table over here, actually over here. And to find the x-intercept, you're always going to use 0 for x, y rather, and solve for the x value. For the y-intercept, you plug in 0 for x and then solve for the y value. Okay, so let's find the x-intercept first by substituting y equals 0 into the equation. We have 4x plus 7 times 0 minus 28 equals 0. 7 times 0 is just 0, so we can just ignore that now and get 4x is equal to, 4x minus 28 is equal to 0. Add 28 to both sides. We get 4x is equal to 28. Divide by 4. Get x is equal to 7. 4 as a point, that's 7, 0. Okay, so I'm going to go over to the x-axis and say the x-intercept is 7, 0. That shouldn't be a surprise because we already kind of knew that was already there. Let's find the y-intercept. The y-intercept, we do it the same way. Because I'm running out of space, I'll do it down here. The y-intercept, we're going to substitute x equals 0. And so we set it up as 4 times 0 plus 7y minus 28 equals 0. 4 times 0 is just 0. So now we have 7y minus 28. Of course, add 28 to both sides like we did in the previous example. So 7y equals 28, and then divide by 7, get y is equal to 4. As a point, that's 0, 4. So we go to 0, 4, and as soon as you have the x-intercept, the y-intercept, you can graph the line. And then here we didn't use slope at all, right? We didn't calculate the slope. We didn't need to calculate the slope. So all you needed is 2 points to connect the line. And we found the y-intercept, 0, 4, and the x-intercept, and we connected the two. But you can see that the slope is down 4 over 7, just like we had in the previous page. All right, down 4 over 7. Okay, I hope you have a better understanding of slope, linear equations in slope-intercept form, point-slope form, and the general form. And make sure that you try this problem out, number 9. All right, take care, and I'll see you back next time.